Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 4 from section 9-7 in the SavvasRealize Algebra 1 textbook. Today's video is about solving systems using substitution. Now I'm going to be real picky here, y'all, just to save you some time. When we talk about systems, this one's talking about linear-quadratic systems. Often when we talk about systems, they just mean linear systems, which is 2 lines, which is like way in, I don't know, topic 1 through 4, somewhere over there. So make sure you're in the right section of the book. This is specifically linear quadratic systems. Alright, so a phone company launches the sale of 2 phones in the same week. The phone on the app is an upgraded, or on the top is the upgraded version of the other phone. Alright, so here's the shiny new one, here's the crappy old one. During what week are the sales projected to be the same for both phones in thousands? And what will be the weekly sales of each phone for that week? So I want to start out with first identifying what the X and the Y stand for. Okay, because that messed me up the first time I made this stupid video. Alright, so the first thing to notice is it's asking during what week. So that's going to be either my X or my Y. And then it's talking about the sales being projected. So the number of weeks is going to be one of my variables, and the revenue, or the sales, is going to be the other value. So we have to think about it. Does the amount of money that you make get determined by the amount of weeks? Or does the amount of weeks that you sell phones for determine the amount of money that you make? Right? Well, the longer you sell something, hopefully the more money that you make. So the number of weeks is going to be our dependent variable, which is our X value. And our sales being projected is going to be our Y value, because that's our output. Because how long we sell these phones for determines the amount of profit. Alright, so now that we got that out of the way and we know what our X and our Y stand for, let's talk about our phones. So the fancy pants new phone has the equation Y equals 20x, and our old junky phone has the equation Y equals negative 2x squared plus 60x. Now, I have the feeling this was a typo from Savvas. The reason why is because quadratics in the long run tend to grow faster than linear functions. We're going to call it good here, but recognize that that seems a little weird to me. Like I said, because quadratics grow faster than linear ones. Although this one has a negative a value, which means it's a downward facing thing. So over time, do you see how it's decreasing? So some of our tips and tricks to help us understand this word problem, make sure you mind some of the details. Alright? So yes, quadratics grow faster, but with a negative a value, it's growing faster in the downward direction. Alright, so kind of touching into the try it here, I could use graphing to get a better understanding of this and to help me to solve this. Alright, and that might have helped me to get through that pitfall of saying, ooh, that one tends to grow faster, they made a mistake. Alright. Now another thing, we just learned how to do elimination in the last example. I like elimination. It's real nice. So I could just kind of stack my 2 equations and subtract them and get an answer. It works the same way. This video, however, is about substitution, so I'm going to show you how to do substitution. But understand that you can use graphing or elimination to help you to get things. They just are different methodologies. Alright, they will still get you the answers that you want. Graphing is not ideal though, because graphing will sometimes not get you very clear answers, right? And elimination, if you don't like to use elimination, well, maybe that doesn't work out for you, all right? Now with substitution, remember what you do is you take one equation and plug it into the other equation. Now notice both of these say y equals, so I could take the red and plug it into the green, or I could take the green and plug it into the red. It doesn't matter. So I'm going to start with the base of the red equation just because it's the long one and I'm lazy. I don't like writing a lot. And so what I'm going to do is, because the green one says y equals, I'm going to go to where the y is on the red equation and erase it and replace it with what the green equation says. And so now I have an equation that looks very similar to what we did in example 2, where we had two sides of an equation we could solve. All right, now I could do that with graphing if I wanted to. I don't want to, but I could. All right. But what I'm going to do is I'm just going to solve this using just arithmetic. So I'm going to get all my x's to one side and see if I could solve the quadratic equation that's there. So this 20x is going to get subtracted. Now notice I'm not subtracting it from the x squared. That's not a like term. I'm subtracting it here underneath the x. All right, and this gets me to the point where I would have been if I was doing elimination. All right, so it's just the initial startup, and then everything else is the exact same thing as we would have done with elimination. So I'm going to either factor or use the quadratic formula. Now there's not a c value here. There's no constant, like a +7. So I'm not going to worry about quadratic formula because this is an easy factor using factoring out the greatest common factor. So between 2x squared and 40x, I see that I could take out a -2, right? Because 40 is divisible by 2, and I don't like a negative in front of the x squared. And I have an x squared and an x, so I could take at least one x out with division. So here, -2x squared divided by 2x is x, and 40x divided by -2x is -20x. And so now we have a product, right? We have this term times that term. So I could use the zero product property to set each of those factors equal to 0. Oops, I put an x after that 20. Silly goose. Remember, if you divide the x out, that x is on the outside now. So watch out, because that's a big mistake that kids make, is they forget to pull the 20 or the x out here. Another way to kind of check yourself is you could actually redistribute that -2x, and it should take you back to the original equation. All right, so here I'm dividing by -2, so I get x equals 0. And here, to undo the subtraction, I'm adding by 20, so I get x equals 20. All right, so let's look at the overview of this problem. So the x is talking about the number of weeks, right? So I could either have a certain amount of revenue at 0 weeks, which is when they haven't sold anything. Well, that would make sense that their revenue would be 0, right? Or I could have it happen at 20 weeks, which is their next point of intersection. So I could either choose to have a revenue of 0 or a revenue of 20. So I'm going to go back with these x values and I'm going to plug it into either the red or the green. Now the green equation is the easy one, so I'm going to plug it in there. So if I plug in 0 to the green equation, I get a revenue of 0, which I expected. If I plug the 20 into the green equation, I get 400, and that's measured in thousands. So there are two intersection points. They have the same revenue at weeks 0 and 20. At week 0, their sales would be $0. And at 20 weeks, their sales would be 400, and then it's in thousands, so I'm going to add a couple more zeros on there. And so that gets both answers in a nice, tidy sentence. Alright, so there we have it, y'all. That is solving linear quadratic systems using substitution. Until next time.